Here we have some properties of logarithms. We can use rewriting it as an exponential to make sense of the first couple. Log base a of a is 1. So as an exponential, it'd be base a to, on the outside is the power, so a to the first equals what was inside the log goes outside of the exponent. So this just says a to the first equals a, which we know anything to the first power does equal itself. So that makes sense. Another property we have is any log base of 1 equals 0. We can rewrite this as an exponent. We would say that a to the 0 equals 1, which we know that anything to the 0 power does equal 1. So here is how we would change that same property in terms of logs. So log base any number of 1 is always going to equal 0. These next two properties, log base a of a, they undo each other. Taking log base and exponent base of the same number will just cancel out and we get x. It's kind of like taking 10 and adding 3, you'd get 13, but then if you subtract 3, you're back at 10. So they're inverse functions. It's like how addition and subtraction cancel out each other, so do exponents and logs. They cancel out and you get the number back in. So if we write ourselves a couple examples of this. So this first property here, log base a of a to the x equals just x. That's like if you had log base 7 of 7 to the 4. Well, log base 7 and 7, they just undo each other and you're left with 4. Same thing the other way. If we write 8 to the log base 8 of 49, the exponent base 8 and the log base 8, they cancel out each other and you're just going to be left with 49. Looking at some log buttons on our calculator, you have a log button that's just log, which really means base 10. So the common log is base 10. And then you also have an ln button on your calculator. That ln button is really log base e. So we can write those same 4 properties from above with these in mind. So log of 10 is 1 because that's just like log base a of a is 1. Same thing with the next one. Log of any base with a 1 is just going to equal 0. The last property, log and 10, will cancel out each other since it's really log base 10. You'll be left with x. And ln of e to the x, you're just going to be left with x as well. They cancel each other out, so 10 to the log will cancel and you'll be left with x. E to the ln will cancel out and you'll just be left with x. Those are the same two canceling properties, just written with these 2 specific bases, which are included on your calculators. So let's find each of the following without even using our calculator though. So just knowing these properties from above. So first, log base 10 and 10 cancel, which gives us 15. Same thing when we move down, 10 to the log of base 10, that cancels, and we're just going to be left with 214. The next piece, we have ln and e, so we want to remember that ln is log base e. So those are going to cancel as well. ln of e to the 6, we're just going to end up with 6. Same thing moving over, we have e to the ln of 20, e and log base e cancel, so we're left with just 20. The next one we have to do a little bit of work. We want to write this, since it's a regular common log, that really means base 10. So I want to write this 1,000 as 10 to a power. So I want to use base 10 to write it. So I'm going to grab my calculator, I'm going to do 10 squared. Well, that's only 100, so I'm going to raise 10 to the 3rd, and that does equal 1,000. So we can write this as log of 1,000 being log of 10 to the 3. That way these can cancel and we'll just be left with 3. Same thing with the one below there. This is log base 2. So I want to write 32 as 2 to a power, that way the 2's can cancel. So I'm going to grab my calculator, I'm going to do 2 squared, that's only 4. 2 to the 3 is 8. 2 to the 4 is 16. And 2 to the 5 that gets me 32. That way we can cancel out the 2's, and my answer is just 5. Moving on to the next page, we have log base 4 of 1 over 16. So this is log base 4. So I want to write 1 over 16 as being a base 4 as well. Well, that's 1 over 4 to the what power would give us 16? It'd be 4 to the 2. And then we know if the power is in the denominator, that really means it's a negative exponent. So this is 4 to the negative 2, really, if it's in the denominator. So that log base 4 and 4 cancel, and we're left with just negative 2. Same thing below there, we have log base 10, because it's a common log. So I'm going to write this as 1 over 10 to a power. So I need to figure out what power of 10 will give me 10,000. So I'm going to do 10 squared, that's only 100. 10 to the third is 1,000. And 10 to the fourth will give me that 10,000 in the denominator that I need, which is really going to make this log of 10 to the negative 4 if it's in the denominator. And now this log and 10 will cancel, and my answer is just negative 4. Moving up to this log base 5 of the square root of 5, we want to remember how to rewrite a square root as a power. Well, this is log base 5 of 5 to the, what fraction is the square root? It is the 1/2 power. And now the log base 5 and the 5 will cancel, and we'll just be left with 1/2. This last one here is one of the properties we said above. We said log of any base of 1 always equals what? Let's look back at these properties. Log of any base, when it has a 1 in there, is just going to give us 0. So from exponents, we remember anything to the 0 power equals 1. For log of any base of 1 always equals 0. So this log base 3 of 1 is just going to be 0.